These diagrams basically try to illustrate the quantity called surplus, which is defined as the difference between the utility achieved by a consumer and the cost it takes to provide that kind of service. Okay. So here's reason number one, illustrated through this kind of demand price diagram. In most economics textbooks, they plot P versus demand of P. Okay, a different kind of orientation of this graph. Here we are plotting D of P versus P. Okay, so this is price on the x-axis and demand on the y-axis. Of course, it's a decreasing function. Let's say it's a straight line for graphical simplicity here. Now, if you pick a certain price point as the carrier, okay, so a piece of U for a usage-based, okay, you say that this is the kind of the unit price I need to provision capacity at this in this scheme here. Then, according to a demand curve with usage price, then you get a certain x sub u as the demand. Now, what is the utility to the user? It's basically the area under this curve. Right? Why? Because u prime inverse is P, is D, right? So if I flip the D curve, I'm going to get a u prime. So turn your head 90 degrees. Okay? You see that this is that curve, right? And then I'm going to integrate this, then I'll get the utility value because I'm integrating the first derivative. That means I look at the area under the curve, and that is this area. Okay? So utility is A plus B. The two areas labeled as A and B. Now, what is the cost it takes to provision this much utility? Well, the carrier is saying the per unit cost is P sub U, and your consumption is X sub U. So the product, that's this rectangle area B, is the cost. The difference is the surplus, and that is the difference between A plus B and B, which is exactly A. So this part is the good part, it's the surplus. Now that's assuming you do usage based. Now what if you do flat? So denote that by subscript F. Well, if you do flat, that's effectively saying that the consumer will consume all the way as if the price is zero. That's a very disturbing pricing signal free. Okay, it skews the demand supply relationship. So now the supply will be all the way to this high. Okay, and therefore the extra cost to provision this is C plus D compared to the usage-based case. This is extra cost is C plus D area. The extra utility you achieve, however, is only area C. So the negative surplus is area D. This is negative surplus. And in fact, you can have enough negative surplus so D can be so big that it overwhelms A. So D can be bigger than area A here. And therefore, even the net surplus becomes negative as you switch from usage to flat in this comparison. So that's reason number one, that a flat rate pricing leads to less surplus because it sends the wrong pricing signal to consumers. Here's another reason, very different one. Here I'm plotting three different demand curves representing three kinds of users, typical users. A light user, X, a medium user, Y, and a heavy user, Z. Okay, so the heavier user you are, the higher your demand curve is for the same price. Now again, if it were a flat rate, then it's as if the price set to zero and you get these three demand consumption points. Okay. Now the price that the carrier needs to charge for the flat rate needs to be high enough, okay, so that the area under this rectangle marked by R must be large enough. Now I cannot control this curve, but I can control this point, so I need to pick the price for flat rate pricing scheme to be large enough so that the resulting R curve is large enough. But if this point is large enough, then you can see that in certain cases, say the light user, okay, the total surplus, the total utility is on the area under the curve, this T region. But the price is this much. So surplus is negative for light user. Now, of course, for the heavy user, this whole area under the curve is the utility. Subtract this cost, surplus is positive for heavy users. For light users, however, it is negative. This quantifies the simple intuition we've been alluding to a few times already. That is, light users subsidize heavy users' lifestyle. And the reason is because flat rate pricing is inflexible. You need to set this to be large enough. And when that happens, the surplus can become negative for light users. Reason number 2. Reason number 3 here. You can have also a carrier think about upgrading the service. Okay, upgrading the service. In order to upgrade service, you have to pay for the expense associated with that. On the one hand, as you upgrade service, the demand curve for every user will be shifted to the right, say under the same shape. Why? Because for the same price, I'll be getting a better service, and therefore the demand will be higher. Okay? And now, on the other hand, the carrier also has to pay more to upgrade and therefore issue a higher price. Let's say, again, it's under this flat rate, so everything's subscribed by F here. You go from P to P bar, okay, so that you can recover the cost. That is, the area originally under this rectangle suffices. Now you need a bigger rectangle. Okay. Now, as you do this, however, you can see that if the user is actually light enough, okay, for light enough, then the surplus, that's the difference between utility, area under the triangle curve, these are the consumption points, minus the cost, that's the rectangle area, is actually shrinking as you go from a lower service to a better service. The surplus actually reduces as you go through an upgrade. Okay. And this counterintuitive behavior is again due to the fact that recovering costs through a single flat price is inflexible. This is reason number 3. Okay, so now somewhere have seen a graphic illustration of 3 quantitative notions using utility and demand curve on these demand price diagrams. Reason number 1 is that it leads to waste. Number 2 is that light user subsidizes heavy user. Number 3 is that it discourages service upgrade in some cases. So there's plenty of evidence. In fact, back in 1998, UC Berkeley had an experiment called index experiment. So one of the few quantitative approaches to suggest why usage pricing is a good idea. But of course, back then, supply per dollar can catch up with demand's projected growth rate, and it was more important to get the market demand going up. So even though it was demonstrated, it took actually more than 10 years for the industry, at least in US mobile industry, to say that we're going to shift to usage-based because of this jobs inequality of demand. All right, let's conclude this lecture with a simple example at this point.